Hopefully I'll connect. There it goes. Well, thank you, and thank you for having me here today. It's a pleasure to speak after Eugene. He actually did a great job covering the background on in-water cleaning and some of the justifications. It's almost like our talks were planned together, but they're not. I'm going to follow up on some specifics that he mentioned, particularly about things like independent testing of in-water cleaning or technologies in general. So my presentation, again, I'm Mario Tamburri. I'm a professor at the University of Maryland Center for Environmental Science. My collaborators in this broader effort include Lisa Drake from the Naval Research Laboratory in Key West and Greg Ruiz at CERC. So what I'm going to talk about today is evaluating in-water cleaning technologies, a project that we're initiating in the States with the goal of facilitating innovations that protect the environment. We're really focused on the invasions side of in-water cleaning, but also business development, helping companies that are interested in developing these technologies. I'll explain a few of these logos as I go through the talk. The talk is going to be broken up into sort of three parts. First, I'll tell you a little bit about a workshop we held last year in the States that was really focused on approaches for quantifying biofouling and considerations for hull cleaning. I'm going to spend a little bit of time then on third-party independent testing and evaluation. And my bullet got kind of truncated there. But then I'm going to talk about the evaluation of water cleaning technologies. That's interesting. Lost some words, huh? Well, let's first just a little bit about the workshop. Just about a year ago, it was August of last year, was held at CERC. Several of you in the room were there as well. Our goals were to consider the approaches for characterizing and quantifying vessel biofouling, but also to identify and discuss existing approaches for in-water cleaning and how we might evaluate those approaches for their performance. We had about 21 people from 15 institutions around the world, including Australia, Canada, New Zealand, and several states in the U.S. The presentations and discussions were focused on things like national and regional regulations and standards, current and future research on quantifying fouling, and then again, this whole husbandry aspect of what the options are out there and how to assess their efficacy. Here's an image of some of the folks that were there. So I'm just going to go over some of the main conclusions and recommendations from that workshop. And I think a lot of these themes we heard about the last few days here, but I think are good sort of reminders. This report is available as a PDF on our website, and I'm happy to email it out to anybody who's interested. First off, and we've heard a lot about this last couple of days as well, is that we're all struggling with the same sort of gaps and needs when it comes to addressing these issues, regardless of country or agency. We're all sort of trying to figure the same sort of issues out. So again, working together, as Eugene mentioned, is I think a really important thing to do. One area that I only heard a little bit in the last talk was this issue of live versus dead. It's something we spent some time on in that workshop, and we feel that it's important to consider this in a little bit more detail. This is an issue in the ballast water world that's caused a lot of problem, and we probably want to think about it ahead of time when we're addressing it in the fouling world. If you're looking at quantifying biofouling and you're looking at it in the context of drag and roughness and so on, then it doesn't necessarily matter if they're live or not. But if you're looking at it as a biosecurity issue, whether that barnacle is alive or not is important, and how to determine whether it's dead or whether the treatment worked in killing it or making it non-viable is a tricky issue that deserves more thought. The workshop also concluded that there's a real need for emphasis on quantifying fouling and its removal. The accepted thresholds still need some work. What is safe amount of fouling? We're not going to have a perfectly clean vessel. So what's low risk, what's high risk? Those numbers are still need to be thought through a little bit. Standardization, particularly when it comes to things like quantifying fouling and for testing in water cleaning technologies, is going to be important. Doing it all in the same way so we have some comparability, repeatability is key to the success of these efforts. I underlined this one because, again, Eugene actually mentioned it several times, but it's something that was an emphasis of the workshop, independent third-party assessments. I'll be showing you a few more slides on that in a second. These last two bullets that came out of the workshop are these important issues of communications that I think we all appreciate. And I'm really glad to hear about glow fouling, because I think they might be able to sort of pick some of these areas up. And that is, we felt last year in August that we should meet on a regular basis annually to discuss these issues, discuss progress and research and so on. And we also felt that there was a need for a central repository for information, a website that captured information on regulations, on protocols, reports, data, and so on. So this might be something that the Globals can help us all with. So we're all working off the same information. It's all easily accessible. So let me spend a few minutes just sort of switching gears from much of what you've heard about this week into independent third-party testing or evaluation, something I've spent a lot of my recent career in science on. And the way I like to think about it is the benefits of this sort of independent testing. And there are benefits to two different groups. Of course, there's the user groups of the technologies, and then there's the technology developers and the funders of that technology development. So you think about it from a user perspective, what you get out of independent third-party testing of whatever technology it is you get awareness and confidence that the technology works to some level of performance you expect. But you also get some input into the process. You get to identify what your user needs are, what your priorities are, to help the technology developers make the tool more suited for your needs. You also get things like de-risking of technologies. It's very common for the first customers of a new technology to be the actual beta test. Well, independent third-party testing can take down that role and de-risk those technologies, make sure they're at least reliable in some sense. You get reliable, quantified information on the quality of the technology, its performance. And if the independent testing is linked to certification or approvals, then ultimately you can get a certified system that you can use, which is your highest sort of level of confidence. From the technology developer side and from the funders of that technology development, you get a lot of benefits as well. These tests help facilitate the maturation of the technology and help you cross that valley of death that you hear about. It often is the downfall of promising innovations. You can increase the rate and probability of transition into operations. The way to think about it is on technology readiness levels. This is something that different groups like to think about how technology mature in the US. The NASA and Department of Defense use this a lot, where technologies start as a basic concept and they work their way up through a readiness level to their fully operational TRL of 9. And to actually, in many cases, to cross from 7 to 8 or 8 to 9, you're required to do a third-party independent test or evaluation of that technology. So it helps these technologies move forward. You help build the market and user awareness and confidence. You get enhanced return on your investment. And of course, again, if it's tied to certification and approvals, then there's no better thing than having your new instrument approved and certified for use. Your customers are going to be excited about that. So I run a couple of programs that do a lot of that sort of work. One is the Maritime Environmental Resource Center, or MERC. It's been around for about 10 years, a little bit more. Its original creation and focus was around the ballast water issue. We're a third-party tester of ballast water management systems, of course, to address invasive species, and also working a bit on compliance monitoring tools, sensors for discharge of ballast water. We're an approved U.S. Coast Guard test facility, and we also test for other administrations in other countries around the world. And we were heavily involved with the verification testing of sensors, again, for compliance monitoring. MERC has also started working on fouling and invasive species. We've done a project with a nuclear power plant on anti-fouling system for the cooling water system. And of course, now we're getting into the in-water cleaning technologies. And ultimately, really what MERC's all about is to facilitate the development and adoption of green ship, green port innovations. The website's here. This is our land-based mobile test platform for testing ballast water management systems. We move it around the Chesapeake Bay and test how well these things work under different conditions. Another program I run is called the Alliance for Coastal Technologies. ACT is getting on to about 17 years old now, and it's a third-party test and evaluation program focused on sensors and sensor platforms for studying and monitoring aquatic environments. So from lakes and streams and rivers to estuarine coastal environments to the open ocean. We work really closely with a variety of agencies in the US. I won't go through all these acronyms, but you might recognize a few. In fact, most of these agencies, like the Coast Guard and EPA and NOAA, rely on ACT as their testing organization for these new innovations, new technologies. And ACT was working with Merck and others on the sensor testing for ballast water compliance tools. We're a forum for capacity and consensus buildings. We have workshops and training exercises. And then we also serve as this information clearinghouse on environmental technologies. We have an online database of instruments, and we have reports and data and so on. ACT website's there. This is our team deploying a series of about, I think it was a dozen or so pH sensors to see how well they work to address issues of ocean acidification. So the ACT approach is we have sort of two different types of evaluations. We have what we call performance verifications. This is where we verify essentially manufacturers' claims on specifications. They say how accurate or precise they are, what their range is, and so on. And we actually test how well how accurate those statements are. They're very comprehensive, very rigorous tests. Done in laboratory under a variety of field conditions. But we also have what we call performance demonstrations. This is where we take young technologies, new on the market, prototypes, and the goal is to demonstrate their potential and their capabilities to help the developers identify perhaps limitations, make them a little bit better maybe, but help user community see what new technologies might be available to meet their needs. These are as rigorous, but usually far less comprehensive. We're going to be using the ACT model for the in-water cleaning, and my guess is we're going to be moving probably towards a demonstration of these technologies more than a verification, but we'll see how it evolves. But ACT itself never compares technologies, never ranks them. We actually write individual reports for individual sensors, for example, and we let the community then decide which makes most sense for them. And ACT also is not a certification program. We rely on other agencies to then take the information and decide whether it's approved or certified. For all this to work, transparency and credibility is key. So we work a lot on objective testing through a community process with lots of input from all the stakeholders, skilled personnel, sound methods. But we also work very heavily in that whole QA, QC side of things. So ISO 17025, but a lot of heavy QA, QC, particularly when you're working on a certified system. I have to show one data slide. I can't do a whole presentation without showing some data. So I snuck one in here for you because it's related to biofouling, and I think you might be interested in this. We heard some talk yesterday about sensors and fouling. This is some work that ACT has did on dissolved oxygen sensors. And these are the two instruments after they came out of the water, and this is their data through time, and oxygen levels are here. One of these sensors had an anti-fouling system on it. It was a mechanical wiper to keep the DO sensor head clean. The other did not. And these red dots are water samples that we did the Winkler's titration to measure oxygen levels. So the good news here is that these instruments both lined up perfectly on each other and the Winkler's titration for the first week or so. But then after about a week and a half, the one without the anti-fouling system crashed because it succumbed to fouling. The one with a wiper lasted maybe a week longer, but after about two and a half weeks, it also succumbed. Fouling is a huge issue for anything you put in the water, including ocean sensors, and we haven't been able to solve that problem yet. I won't go through all this, I promise. I just wanted to show you, though, this is the process for an ACT evaluation, and this is something we're going to try to implement for the in-water cleaning technologies as well. It goes through a whole series of steps, but a couple of points I want to make is that we work hard on identifying what the user needs are in these technologies to make sure the tests address those priorities. We put together a technical advisory committee for all of our evaluations, and including the in-water technology work. So we'll be asking experts to help us out, both in developing the test plans as well as reviewing the final reports. We release a request for technology. It's a voluntary program, and we don't charge for the services, but companies have to apply to be part of the testing. If they meet the basic criteria, we let them in. Again, we don't charge for the services, but there's obviously some contributions that are required from the companies to bring their technologies for testing and so on. There's a whole series of application steps and finalizing protocols through workshops and QA, QC, and et cetera, to the release of the reports, which are, again, peer-reviewed with our technical advisory committee before they're released. So when it comes to in-water cleaning in particular, here's our fundamental goals: to provide this independent evaluation of these technologies. Again, designed just to support the maritime industry, but also to help stop the spread of invasive species. So our target really is mostly on biosecurity and not as much on the fuel savings and so on. We want to work on facilitating the transitioning of these new innovations into operations and into other applications. I mentioned ships and platforms here. I'll tell you what that means in a minute. And then hopefully through providing this rigorous third-party testing on the performance of these technologies. And when we talk about performance, what we mean is removal of the fouling organisms, their capture, hulls, and in niche areas. Those details are more complex. We're going to be working a lot with what folks in New Zealand and MPI have already done to build off that sort of work. But the idea is to help these things become commercially available and approved for use in ports around the world. So I mentioned platforms. I was having a conversation with a friend of mine from Spain who works in the Canary Islands, and we were talking about ballast water, and we evolved into a discussion on platforms. He said there's a huge concern there in Tenerife and Las Palmas. This is actually Tenerife here with a couple of platforms. Not only are they a big shipping hub in the Atlantic, but they're also a way station for offshore oil and gas rigs. Things can be decommissioned in the North Sea. They'll go to the Canary Islands, sit there for months before they're transported somewhere else, West Africa, for use again. And they're obviously heavily fouled, and there's lots of concerns for invasive species and ecotourism, and they have no idea what to do. How do we clean these things safely? What should we do? So they want to get involved in this project. So Spain is going to be contributing some resources to this work to include an evaluation or a participation of cleaning of offshore platforms. We know this is going to be a complex sort of thing, that many of the technologies that are designed now are really focused on ships, but there's also now an emphasis on niche areas. These platforms are one big niche area, if you will. We know they're not perfectly designed for this, but through this process, we're bringing some awareness to this issue, helping to drive technologies in another application that might be useful. So here are the steps in what we have planned for the next year or two. What we're doing right now is going through a review, like many of you have, and are being published, I've seen in several places, on the current state of technology for in-water cleaning. We want to make sure we understand the playing field and what's available. That's underway. We're also starting to look into the relevant regulatory and permitting requirements in the States, in specific locations like the Port of Baltimore, but also internationally. If these are going to be approved, what data do we need to provide for their acceptance? When I get back from this meeting, we're going to start working on things like developing our technical advisory committee to help us, and to start drafting our test protocols, at least the framework for the protocols. Of course, we're going to build off of and try to standardize as much as possible with existing protocols, like we heard earlier about MarEST et al. 2015. So that's going to happen over the fall. We're going to release a request for technologies and hopefully get applications from a few different in-water cleaning providers later this year. And then we're going to work on a workshop in February, likely in Baltimore, with our technical advisory committee, our testing team, and the participating companies to finalize what those protocols finally look like, how it's actually going to work. Field testing we hope to initiate in spring in Baltimore, and we're going to be using U.S. Maritime Administration vessels. MARAD is one of our sponsors and funders of this work, and they're a great partner on all this. And they also have a ready reserve fleet. We have a couple of rows that we've been working on over the years. They're designed like commercial vessels, but they don't have the same operations. They're not doing cargo operations. So they're fouled and they're coated the same way that most vessels are, but they sit in the same spot for extended periods of time, which allow us to go in and do some of this testing over a couple of weeks before and after cleaning in different locations and so on. So that's hugely valuable. As part of those field tests, if you will, of these technologies, we're also going to be looking at some economics of this. We want to make sure that this is an economically viable approach as well. So we've heard a lot about cost savings from fuel consumption and so on, but what is the real cost for cleaning these vessels, including things like niche areas and capturing? Is it a cost that's acceptable to the industry? Can we regulate requirement for this if the cost is reasonable and so on? So we have environmental economists on our team that will be helping with that. Later in the fall is when we hope to get to Tenerife and start looking at offshore platforms. Again, we know this is a bit of a stretch, and we know some of these technologies aren't really geared for that sort of application, but that's our goal, and we hope we can entice a few to give it a try anyway. And then we'll work up the data and write reports. We say by the end of the year, but sometimes it takes a little longer than we all hope, right? So I'll just end there with my last slide that has a few acknowledgments, but I first want to say that what we're trying to do is a part of this project is to make sure we're doing this sort of work in a standardized way that we can all sort of benefit from. So if others are involved in similar activities, we would like to coordinate, we'd like to share resources and expertise, collaborate whenever possible. So please let me know if you're interested and want to participate. Our funders for this work is the U.S. Maritime Administration, as well as the Maryland Port Administration, Port of Baltimore. What Port of Baltimore is really interested in is that can they help business development in the port? Can private companies come in and provide a service that helps local businesses, but also helps them attract customers to the port? Ships will come in saying, well, I can also get clean and do cargo operations, right? So they're very interested, and we're coordinating this work as well with the California State Lands Commission. Chris's name keeps popping up this meeting. And then Carolyn Juneman, I want to thank, who's at MARAD, who's been helping us with a lot of this work. So I will stop there and be happy to answer a question or two if there's time. Yeah, thanks.